Today's notes are on solving one-step equations for multiplication and division. And so we can actually make this our I can. I can solve one-step equations for multiplication and division. And so remember, the goal of solving equations is to isolate the variable. When I say isolate, I mean to get it by itself. So we're trying to get the variable or the letter all by itself to figure out what number it is equal to. So in order to do this, we are going to isolate the variable by using that vocabulary we learned by using inverses. Specifically, when we talk about multiplication and division, it's going to be using the multiplicative inverse. So we'll be doing undoing, multiplying, or dividing. Yesterday, we talked about how we undo addition and subtraction. Our inverse operation is to do the whatever would make it turn 0. So if I add 23, I would have to subtract 23 to undo it. If I'm subtracting 18, I would have to add 18 to undo it. But then, when we talk about multiplying and dividing, to multiply by negative 15, you multiply and divide by the exact same number, okay? So if we're going to be multiplying by negative 15, we will divide by negative 15. If I'm dividing by positive 8, I will multiply by positive 8. Notice the signs don't change when we're multiplying or dividing. And why we are doing that is because we are trying to make 1. When we multiply or divide, instead of making 0, like adding, subtracting, we're trying to make 1. We need a 1 in front of that variable in order to solve. Unlike when we added, subtracted, we were making 0. Okay, so there's a little difference when we multiply and divide. We have 2 examples to work through. The first one says we need to solve x times 8 equals 56. Anytime you see something like this where my number and variable are smushed together, it's being multiplied. So keep that in mind. This is multiplication. We just don't always see the times symbol. If you want to squeeze in a little multiplication dot, you can. And I see my variable x right there, so I need to get rid of the number that's in front. I need to get rid of this 8. And so it's being multiplied. So to undo it, we have to divide. And we have to divide by the same number. So I'm going to divide by 8. So down here, they show us we don't use the division symbol anymore. We're going to use a line, a fraction bar. 8x divided by 8. And if I do it on one side, do it on the other side. 56 divided by 8. Because what happens, 8 divided by 8 makes 1, and I'm left with just my x. 56 divided by 8 equals 7, and I have my answer. And we can check by plugging 7 back in. So we can plug in 7 into the problem. 8 times x equals 56. 8 times 7, is that equal to 56? Well, 56 equals 56. It's all good to go. When we still draw that line, it just makes it a little harder to see here. Now, this problem over here is division. We won't be seeing division symbols. We now see fraction bars as division. So that problem right here says a divided by 5 equals 12. Draw that line through the equal sign, and I see my variable a is what I'm trying to get along. And it's being divided by 5. So to undo that, we will multiply by 5. Same number, 5. And if I do it on the left, I do it on the right. What happens here, though, The 5s are going to cancel to make 1, which leaves me with just an A. And then 12 times 5 can be multiplied to find my answer of 60. So when I check, I'm going to take 60, plug it in for A. So 60 divided by 5, is that equal to 12? Well, yep, 12 equals 12. It works. I have the correct answer.